So you might have seen this topic in GCSE. We're looking at series, and the type of series that we're looking at in particular are ones that just go up in a very simple way, add something, add the same thing, or subtract, add or subtract. So this is called an arithmetic sequence, and it's one of the topics in C1. And so first of all, I'm just going to talk about the important notation. So, first term we call A.
Yeah.
Always we use A for the first term. Now an arithmetic series by definition goes up by adding something or subtracting something, and the letter that we use for that is D. So here D is 5. So we're going add D, add D, add D.
Is that the difference between two numbers?
Yeah, difference, D for difference. It can be subtract or it can be add, either is fine. And it's called the common difference because it's the difference which is common because it's the same one. So that's the common difference. And then we use n for the number of terms in the sequence. So always these three letters we're going to be using, no other letters. So in this one, obviously we've got A is 4, the first term is 4, we've got D is 5, because the common difference is 5. Number of terms I'll come back to, because I can see what the final term is, it's 124, but I don't know how many there are. Okay, so first thing to notice, if the first term is A, and then we get to the next one by adding on D, then definitely this one will be A add D.
Yeah.
And then we add on D again. So the next one will be A add D, add 2 Ds.
Yeah.
And then we add on D again. So now we've added on 3 Ds. So this one is A add 3D. And then we just keep going and keep going. And what you can see is that the first term, A add no D almost, is A. Then the second term, A plus D. Third term, A plus 2D. It's always one less D than the number of the terms. So the fourth term, 19, here, fourth term was 19, and the fourth term is A add 3D. So the number of Ds that you add on is one less than the term because the first one is A add no D. So this one here, for example, 69, I don't know which term it is, but it will be A plus something amounts of Ds will be 69. Now, I know what A is. It was 4, wasn't it? Don't know how many Ds I've added on, but D was 5. So I can actually work backwards and say, well, how many times have I added 5 to 4 to get 69? So if I take 4 off each side, for example, 65 is don't know amount of 5. 65 divided by 5,
13.
is it? Well, I did that very quickly.
A factor of 12 is 6, isn't it?
I don't know.
It's
Actually, one of the hardest things about arithmetic sequences is it's in C1, which means it's non-calculator. So you would have to actually do 65 divided by 5 yourself. So the number of times that we've added 5 on to 4 is 13. So to get to the 69, we've gone add 5, add 5, add 5, add 5, add 5, 13 times, which means that this is the 14th term, because we've added n on 13 times. Now we can do the same thing here. We could say 100, at the end of the sequence, we could say, well, we know that 124 will be A plus D, and the number of times that we've added D on is 1 less than the number of terms. So if there are 10 terms here, the final one will be A add 9D, 1 less. So we know that 124 is the first term, 4, add the total number of terms but 1 less, because that's how many Ds we've added on, and the D was 5. So 120 must be 5 lots of n minus 1. So 120 divided by 5? Is it 24? Okay, so 24 is not the number of terms, it's the number of terms minus 1. So the number of terms must have been 25.
So that's 124 is the 25th.
Yes,
Number.
the 25th term. So first term, second term, third term, fourth term, to the 14th term, 25th term. So A add 24D is the 25th term. Okay, so we get these very important formulae, which I'll come back to in a minute, but a plus n minus 1d for the nth term, that's one of the important things. Okay, another question that we can ask is, what do all these terms add up to? And I'm going to show you a very clever way of working it out. So, the total, S for sum, is going to be 4 add 9, add 14, add blah blah blah, add, well the last one would be 124, the one behind it would be 119, I think. The one behind that would be 114. So that's what we're trying to add up. Now, do you agree that that's the same as adding up 124, add 119, add 114, add blah blah blah, add 14, add 9, add 4?
I do.
Yes. Yeah, because it's just
doing it in the opposite.
yeah, it's just doing it in the opposite order. They add up to the same thing. So, do you agree that 2s would be these two, add these two? If you added up literally the whole thing, all of them and all of them, so that's 128, add 128,
Yeah.
add, 128, add 128, 128. Because what's happening is that this, from 4 to 9, is add 5. And this, from 124 to 119, is minus 5. So this 119 is 5 smaller than 124, and 9 is 5 bigger than 4, so the total is going to stay the same. So all of the totals are going to be 128. How many lots of 128 have we got? How many terms did we decide?
So we had
25 terms. This is the first term, second term, third term, all the way across, and we decided we had 25 terms. So there must be 25 lots of 128 there. So 2 lots of the total is 25 times 128, which is, okay, how about this? How about 128 times 10 is easy.
Yeah.
So 108 times 20 is 2 of those. So that's 20 lots of 128, and then I need another 5, but 5 lots of 128 is half of, oh my goodness, I think I'm overcomplicating this. Half of that, 640?
Yeah. Yeah.
So if I add the 640 on, yeah?
Other way I was thinking about was 25 to 104, isn't it?
Yeah.
128.
Yeah.
So that's 12800 divided by 4.
Yeah.
That's 12. Sorry, 12 into 4 into 12 is 3200.
Oh yeah, that's probably easier.
I mean, that's quite nice because you never lose your place, you know, you just add in chunking method.
Yeah.
But
Yeah.
I mean, if it's something nice like that, it's
Yeah.
kind of quite nice to do, right?
And then, so that's 2 lots of the total. So the total is half of that, which is, 1500 add 100 is how I think of it, so 1600. So it's a really clever way of adding it up. And what that gives us is a formula for a general sum of a series. Now, this is comes up in exams. It's worth about half a grade, prove the sum of the arithmetic series. So if you're drifting off and falling asleep and thinking this is boring, you need to wake up, and this needs to get written down because this could easily come up in the exam. So we're going to do the same thing, but abstract. First term, second term, I don't need to write any more, to be honest. The third term will be a plus 2d, but whatever. Right down the other end, final term, so this is the nth term, exactly, because you always add on one less amount of d than the term. And then this one, the one behind it, n minus 2d, so another, you're taking away d if you're going backwards. Okay, so then what we did, that's all the terms added up. Then we're going to write them in the opposite order. So a plus n minus 1d, a plus n minus 2d, all the ones in the middle, the second term, and then the first term.
Yeah.
Then we're going to add up downwards, so we're going to get two lots of the total. And remember, this is always going to be the same thing, like we had 128 before. So it's going to be 2a add n minus 1d.
Yeah.
And 2a add n minus 1d, and 2a add n minus 1d, and 2a add n minus 1d. All the way across.
I can put a question for you. Say you were particularly strong at your algebra. How has that n minus 2d gone with plus d gone to n minus 1d?
Oh, yeah, good point, good point. So, I mean, partly, you know they're all going to be the same, because that's the point, is that in this direction, you're getting add d, and in this direction you're doing add d, and then in that direction you're doing minus d. So obviously this total must be the same as this total, but it's a good point. If you actually look at this, a add a is clearly 2a, but what's happening here? Well, if you expand out these brackets, you get n times d minus 2d add d, which is n times d. Take away 2d, add d is take away d. And then what you can do is factorise out that d. And n times d, so that would be an n, and then minus 1. Sometimes students do find it a bit tricky getting their heads around the fact that d times n minus 1 is the same as n minus 1 times d. And at GCSE you're always taught to expand out brackets like this. So sometimes the brain has a bit of a tantrum about expanding them out that way, but it is exactly the same thing. D times n here, and d times minus 1 here, n times d, d times n, same thing, minus 1 times d, d times minus 1, same thing. So yeah, it's a good question. Okay, so we've done 3 lines of the proof. So just to tidy this line up, how many 2a plus n minus 1d's have we got?
Well, if we know that you've got n minus 1 in this formula, then it must be n lots of.
N lots of it, yeah. This was the first term here.
Yeah.
This was the second term. We said we had n terms.
Because we had n minus 1 and
N minus 1d, that's the nth term. So we've got n of them.
Yeah.
So final line, that's 2 lots of the total. So the actual total is half of that. 2a plus n minus 1d, n over 2, 2a plus n minus 1d. So this is the formula for the total that we use. There's another one which I'll tell you in a minute, but this is the proof of that formula, and this is the sort of proof that you do need to learn. It's only 1, 2, 3, 4 lines long. I mean, I think in an exam you probably need all these lines, 1, 2, 3, 4, 5 lines of working, but it's not difficult to memorise, and it's a good half a grade if they do ask that question. So we've got 2 important formulas. The nth term, A is the first term. We go add d, add d, add d, add d, add d, add d, and the number of times we add d is 1 less than the term we're going for. So that there says the nth term is y.
Yeah.
The sum we now know is n over 2, 2a plus n minus 1d, is y. Now, there's another way of writing this second one. If we fiddle around with this in this bracket just for a minute, instead of writing 2a, I'll write a add a. Happy with that? And then I'll put the n minus 1d. Same?
Yeah.
Okay.
Yeah.
How would you describe that?
That's the nth term.
It's the nth term, isn't it? And this?
It's the
First term. So the nth term, if there are n terms, this is the last term. Agree?
Yeah.
So another way of writing this formula, the sum, is to think of it instead of n over 2, 2a plus n minus 1d, which is what we usually use, that's where the formula comes from, is to think of it as n over 2, first plus last. And sometimes that's a much easier way, y, whatever. That's a much easier way of...
Particularly, I guess, if they're just asking you for what is the sum,
Yeah,
then
yeah.
it's easy to remember that.
Well, yeah, if they tell you the first term and the last term, then instead of having to go through the trouble of finding out what d is, you can just use this. It doesn't involve d at all. It's just the first term and the last term. So we've got three formulas. The nth term is y, a plus n minus 1d is y. The sum of the first n terms is y, n over 2, 2a plus n minus 1d is y, or n over 2, first term plus last term is y. So these are all formulas which you do have to learn. They're not in the formula book. Actually, that might be a lie. One of them might be, but I don't know. To be honest, it's better to just learn them. Okay, so it seems easy so far, but this is the problem, that students read arithmetic series questions, which are usually some bizarre scenario about someone opening a bank account or taking steps forward or reading a book or something with a load of words and a story that we don't care about, and they get muddled and confused. So what we're going to practice is how to untangle the actual question and turn it into nice, fairly easy maths, okay? So what we need to do is translate the information that's given to us into formulae, because we're going to be given information in words, and we don't want it in words, we want it in formulae, so we're going to translate the information. So it's all about translation. Okay, so someone says to you, the nth term is y. You do not write down that. No, no, no. That is not a formula. It's not helpful. It's rubbish. So if I say the fourth term is 21, you do not write down that. No, not helpful, not a formula. What we're going to write down is the fourth term. That says the fourth term. The fourth term, that's the first term and then 3 Ds. The fourth term is 21. That's what we're going to write down. That's what's going to give us an equation that we can deal with. Okay? So, in general, the nth term, what was the formula for the nth term? A plus
n minus 1.
Yeah, n minus 1 Ds. That says the nth term, the final term, or whatever it is, the nth term, is y. Okay? And we're told that the sum of the first n terms is y, then we don't write down sum equals, we write n over 2, 2a plus n minus 1d is y, or n over 2, first term plus last term is y. So this translation is all what it's all about. Once you've translated, you will have two equations, and you will just do simultaneous equations to solve them. So it's all about the translation. Okay? So you've got a pack with these in. You're going to try and translate them. Pause the video, see if you can do it yourself, and then we're going to go through what the translations are. Okay, let's see how you got on translating the information. First one, the fifth term is 11.
So that's going to be the start.
Yep.
With 4 D's added onto
Yep.
it.
Perfect. Next one, the eighth term is 7. A
Start.
plus 7D is 7. Yep. The sum of the first 8 terms. That is the formula, but we know what n is. Yeah, exactly. The formula is n over 2, 2a plus n minus 1d, but n, we're being told, is 8. That's it. That's it.
Oh, so then we can do some fiddling around with that, can't we?
Yeah, exactly. So this is your n here,
Yeah.
and this is n minus 1, so that's obviously just 7. So the translation of the sum of the first 8 terms is 12, is 8 over 2, 2a plus 7d equals 12.
I think probably when I was starting out on this, I might keep writing that formula A to help me remember
Yeah,
it. And
yeah.
then B, just because then I know I've got it, and if I
Yeah.
at any point go back to this and go, oh, what was I doing?
Yeah, I think it's just the point is to know that this is n.
Yeah.
Not a, not d, not
Or
nothing.
not something, yeah, weird, yeah.
Not irrelevant. It is n. Yeah.
I've got it again here.
Yep.
So we've got 18 over 2.
Yep. N over 2.
2a plus 17 is minus 2.
Perfect.
Oh,
Yep. Okay, the 12 term is minus 17. So a plus how many d's?
11.
11 Ds. Perfect.
Some of the first 9 terms, I could do 2a plus 8d.
Yep. N over 2, 2a plus n minus 1d is whatever it is. Yep. 17th term a plus 16d. Good. Some of the first 52 terms.
2a plus 51.
Yeah. D. Yep. Excellent. The 11th term is a plus. Good. 10d is 9.
And then sum of the first 6, that's 6 over 2, which
Yep.
is 3. 2a plus 5d equals minus 8.
Perfect. So, you will be given words, you translate the words in this way, and then say your question is this information and this information, you then do simultaneous equations. That's how you solve to find the A and the D. Do simultaneous equations to solve. Substitute one into the other, solve the simultaneous equations, and you're done.